Hey guys, Mr. Langley here, and I wanted to step in and do some of these example videos for Chapter 10. I appreciate Mr. Funfar taking the lead with Chapter 9, but this is in Section 10.1. We're going to take a look at examples 1 and 2 here. So our first problem, we have what looks like a cube. Now, we're not specifically told that it's a cube, and we want to be careful about assuming. If we really didn't know anything about this, the best we could technically say would be that this is a quadrilateral prism. But we're going to make a couple assumptions here, even though that's something that we need to be very careful about. And let's say that this is a rectangular prism, um, or if we knew that we had right angles in each of these corners, we could also say that that is, and all of the edges are congruent, then we could say that it is a cube. But to be a little safer, let's just say rectangular prism. We're also asked to name the vertices, the edges, and the bases. A good thing to initially do before naming them is to just count them. Vertices, we can see we have each point labeled. We have 4 on the top, 4 on the bottom, giving us a total of 8. The edges we know are the sides connecting the different vertices to each other. So we have up here 4 edges there, 4 edges on the bottom, and then 4 edges running vertically, giving us a total of 12 edges. And then the bases, well, we can only have 2 bases in a prism. Typically, when we look at a picture, that's going to be the top and the bottom, but that does not have to be the case. Especially in this prism here, we could have any of these faces around the sides also serving as bases. But technically we can only have 2 bases. But if we were changing that word and we wanted to look at a face, in that case we would have 6 faces on this prism. The names for each of these, the vertices, are just named with their letters. So we would have A, B, C, D, E, F, G, H. You get the idea. I don't need to write out every single point. The edges are all segments, so you're naming all 12 possible segments that we have here. For example, AB would be one segment, BC would be another, and using proper segment notation to name all of those. Lastly, for the bases and the faces, again, those are two-dimensional objects, so we're naming each of these rectangular faces. If this is truly a rectangular prism, we could name these as different things like A, B, C, D, if we wanted to name that rectangle, or a parallelogram. Okay. Our next two, actually we have 2 example 2s, so we'll take a look at both of them, is talking about nets, and you see the definition of a net right there. It's a 2-dimensional representation of a 3-dimensional figure. This is probably a very familiar net that we see in our first example 2. If we were to know that all of these faces were squares, then you're going to fold this up, and each face is going to be a square, giving us a cube, okay? Something that resembles this 3-dimensional shape. Okay? So this would be, if this is in fact all the sides congruent and right angles, this would be a cube. Our other examples, we're trying to identify what nets give us the 3-dimensional shapes. A couple of these stand out as being a little easier than others. Our first one is arguably the trickiest. With this one, we're going to have this circular base, and then look at how this curved part would wrap around the circumference of that circular base, all kind of leading up to this vertex point right there. This would give us a cone. as our three-dimensional object. And you could think of this, sometimes you'll see paper cups in a shape like this made from this type of net. In letter B, we're going to have our base right there as our internal face, and then these sides are going to fold up to this apex vertex, giving us a triangular pyramid as our object. And then lastly, letter C, we have a cylinder with our two bases right there as the two circles, and then this is the lateral face wrapping around, giving us an object that kind of resembles a cylinder right there.